Hello everyone. The title of this video is section 8.3 on rational exponents, or fraction exponents, fraction powers. So in this video I'm going to be going over a version of the Newton-Alta assignment for section 8.3. Please understand that the version I do in this video may or may not have the same questions that you'll see when you work on the assignment on your own. But the objectives are the same, the questions will be similar, the way I go about doing them would be similar to how I would expect you to do them. So hopefully this helps you in some way when you're working on the assignment yourself. Alright, and another request I have is that whenever a new question pops up, pause the video and try to work on it yourself first before you watch me do it. Because if you're just watching me do it, without practicing it yourself, chances are you're not learning all that much. Alright, so on the assignment page here, right, you're not going to see the words preview of. You'll just see the title of the assignment, the mastery bar telling you how far along you've gotten, the objectives. Looks like there are 3 objectives in this assignment. And then below every question, there should be a feedback button, so you can send feedback to Newton. You will not see the instructor cheat button, right? That's for instructors only. But you will see this more instruction button, which is useful, when you're struggling with a particular objective. It'll provide you with extra reading material and or videos that will hopefully help you. Alright, so this first question is on the objective, simplify an expression with rational exponents and a numerator greater than 1. Right, so a fraction power, you see this is tiny, but it says, negative, and then you have 16 to the 3/2 power, right? The power is a fraction. The exponent is a fraction, and it's a fraction whose numerator is, greater than 1. Alright, so I'll write this out, and then we'll talk about, I'll give you a little lesson on fractional powers. So like I said, this is now, notice that the negative sign is not in parentheses with the 16. So that means, the only number being raised to the 3/2 power is the 16, not negative 16. Right? The negative sign is like having a factor of -1. Right? This is the opposite of 16 to the 3/2. So that negative sign is going to stay throughout the entire problem. Alright, so let's go over here and talk about fraction exponents or fraction powers. Alright, so before I get into actual fraction powers, you have to recall one property of exponents. Remember this property of exponents, that if you take an expression, say x, and raise it to the mth power, and then you take that expression and raise it to the nth power, so power to a power, remember this power to a power property? This would be equivalent to x, right, the base, raised to the product of these powers, right, to the m times n power. So if you recall this, that would be quite useful. Right. One other thing to recall is that, remember radicals, remember the nth root of some expression raised to the nth power, they kind of undo one another, and I'm left with just x. As long as this nth root of x is a real number, right? Because we're only going to deal with real numbers. Same thing with the other way around, right? I remember the, remember the nth root of x to the nth was equal to one of two things, right? It was equal to just x if you were doing an odd root. It was equal to the absolute value of x if n was an even root. And again, I guess back up here, if the nth root of x is real, then this rule works out too, right? So hopefully you recall all this stuff. Right? I know it's a lot, but stuff you should have seen at some point before with radicals. So now let me ask you, if I take 2 to the half, look at fraction powers. If I take 2 to the 1/2 power, right, 2 to the 1/2 power, and you raise this, say, to the second power. Well, by this power to a power property, this would be 2 to the, now 2 times a half, 1/2 times 2 power. And what's half of 2? That's 1. That's 2 to the first power, or just 2. But we also know this, that if you took the square root of 2 and raised it to the second power, you would also get 2, which is the same thing. So if you take 2 to the half and square it, you get 2. If you take the square root of 2 and square it, you also get 2. So this tells me that 2 to the half and the square root of 2 are the same number. All right, and this is just one example, but this is telling me that 2 to the 1/2 is the same number as the square root of 2. And in general, right, this will happen. Right, in general, some number to the 1/n power, see, this is 1/2. Well, when I had 1/2 here, I ended up with a square root. 2 in the denominator gives me an index of 2. So x to the nth, x to the 1/n power is the nth root. It's the same number as the nth root of x. And this is where we're getting our fraction powers. This is a rule that takes us from fraction powers to radicals and radicals to fraction powers. And then a little note off to the side here, the denominator of the fraction, all right, the denominator of the fraction power denominator, right, the denominator of the fraction is the index of the radical. And vice versa, right? So if you see a radical, right, if you see a radical, say the cube root of, 2x or something like that, this would be 2x. All right, so the radicand is the base. I guess that's another note I should put. The radicand is the base of the exponent. All right, x here, x is the base of the power. So the radicand 2x is the base of the power. And a cube root is the same as raising to the 1/3 power. All right. Now, this is the rule for when the numerator of the power is 1. All right, when the numerator of the power is 1. Now, once again, we come back to this power to a power rule. If I were to take something to the m over n power, right, where the numerator is not 1, but say m, you could think of this in one of two ways. One, think of this as x to the mth power raised to the 1 over n, right, because m times 1 over n would be m over n, which if you wrote as a radical would be the nth root of x to the mth power in the radical, in the radicand. Or the second way to think about a fraction power with a numerator that's not 1, x to the m over n, is switch these. You know, m divided by n is the same as, 1 over n times m. All right, again, using that power to a power rule here. X to the 1 over n raised to the mth would give me x to the m over n, and this would be the nth root of x to the mth power. All right. So here's a much more general rule. All right. A rule for any fraction. When you raise something to any fraction, you can think of it in two different ways. All right, you can, and that's what I'm going to do. I'm going to write all these fraction powers as radicals, and you can do it in one of two ways. And I'll show you that both ways should be equivalent. All right, so let me show you going back to this question here. So again, I'm going to keep coming back to this rule. All right, I'll keep coming back to this. So I'm just going to fold this up here and put it on screen once in a while. So there's our fraction power rules. All right, how to go from fraction powers to radicals and back. All right. So back to our first question. We have -1, right? The opposite of now 16 to the 3 halves. You can think of 16 to the 3 halves in two different ways. The first way to think about it would be 16 to the 1/2 to the 3rd, which as radicals, 16 to the 1/2, the denominator is 2, so the index will be 2. This is a square root. That's the square root of 16 and then raised to the 3rd power. So the denominator tells me what root I'm taking of the base. So I'm taking the square root of 16 and then raising it to the numerator power. So this would be equal to 4, right? Square root of 16 is 4. To the 3rd power would be 64. And this is what I'm going to enter. Well, don't forget the minus sign, sorry. Minus here, minus there. Because it's times -1. So this the opposite of 16 to the 3 halves, this is -64. Or you could think of it this way. Right? Now I like that way personally. I like taking the root first, using the denominator, and then raising that to the numerator. I like doing that personally. But you could also think of 16 to the 3 halves in the following way. Do 16 to the 3rd power and then to the half. which is the square root of 16 to the third. Now 16 to the third power, that'd be 2 to the 12th, because 16 is 2 to the 4th, and 2 to the 4th to the third, that's the square root of 2 to the 12th. And remember, square root of 2 to the 12th would be 2 to the 6th, right? Because 2 to the 6th squared would be 2 to the 12th. And 2 to the 6th is 64. And then again, we're just throwing a negative sign in front of that, right? Oops, sorry. So either way you look at it, you end up with negative 64. Right? You end up with negative 64. All right, so that's what I'm going to enter. Now be careful. Right? Be careful with your minus signs. All right. We saw just now that negative 1 times 16 to the 3/2 power is negative 64. This is totally different than negative 16 to the 3/2 power. Look at the difference being the parentheses. In the first expression, the one we were given, the negative sign's not in parentheses with the 16. So the only number that's being raised to the 3/2 power is 16. But down here, the negative sign is part of the base, right? It's in parentheses with 16. So the number being raised to the 3/2 power is negative 16. Now watch this. Right? Again, you can think of this in two different ways. I can think of this as negative 16 to the 1/2 to the third. Or as a radical, this would be the square root of negative 16 inside raised to the third power. But wait a minute. The square root of negative 16 is bad. Right? Remember, that's not real. I hope you remember, for even roots, the radicand, right, the expression inside can't be a negative number. That's not real. And that's all we're going to write for right now, right, if we see that. Later on in Chapter 8, we'll talk about how to rewrite this as what they call an imaginary number. But for right now, I'm seeing the square root of a negative, an even root of a negative number, not real. So I'm not going to get negative 64 again, right? And then the same thing the other way, right? Or you could look at it this way. Say this is equal to negative 16 to the third power and then to the half, which would be the square root of negative 16 to the third power. But again, this wouldn't be real because I'm taking this square root of, and a negative number to an odd power would be negative. So either way, you say, hey, this isn't real, negative 16 to the 3/2 power. But this, the opposite, or negative 1 times 16 to the 3/2 power, that's negative 64. Right, so please pay attention to your parentheses. Okay, so that's what I'm entering, right? Just negative 64. And after every question, whether you get it right or wrong, you should be seeing an answer explanation. Please read through them, whether you got it right or wrong. If you got it correct, read through it, glance through it, just to make sure you got it right for the right reasons. You didn't just get lucky. Or maybe they did it in some alternate way that you like better and might want to use for future questions. If you got it wrong, right, definitely read through the answer explanations as you're trying to figure out where you went wrong, right, so you can learn from your mistakes and do better in future questions. All right, so next question. So now we're on this objective. Use the properties of exponents to simplify expressions with rational exponents, right? Fraction powers. All right, and read the instructions here. Enter your answer in exponent form. So you've got exponents and radicals, right? You've seen the radicals, that's the square root, cube root, those symbols. They want you to leave things with exponents here. So again, and now if they said radical form, then you'll be entering the roots, square root, cube root, fourth root, whatever. So once again, I'll write this out and work on it on a piece of paper. All right. So another property of exponents that's going to be necessary here is the product rule. If you take a product, say a times b, and raise it to a power, right, say the mth power, you can write it, put that power on each factor. This would be equal to a to the mth power times b to the mth power. Right? So there's another property of exponents that hopefully I'm sure you've seen before. Right? That's going to be employed here. So this, again, notice the parentheses around the entire expression, 64 times s to the 3/7. So this is all being raised to the 1/6, and this is a product. So I'm going to do 64 to the 1/6 power times, and then the s to the 3/7 will also be raised to the 1/6 power. Now 64 to the 1/6 power. Now that's the same thing as the 6th root of 64 if you want to do that off to the side. Remember, this is the same thing as the 6th root of 64 if you want. Now if you were to break down 64 completely, 64 is actually 2 to the 6th power. 2 times 2 times 2 times 2 times 2 times 2. So this is 2 to the 6th to the 1/6 power times, and then I'll rewrite this again, s to the 3/7 to the 1/6 power. And now I have a couple scenarios where I'm doing that power to a power rule. So 2 to the 6th to the 1/6 power would be 2 to the 1st. And remember, this is an even root. So the result, the principal even root, the results need to be non-negative, which this is. Right, this is. And then here we have s, right, times s to the, and then off to the side I'll do, we're doing 3/7 times 1/6. But you can do some canceling right now, but this would be 3/42, right? 3 times 1, 7 times 6, or 1/14, right? Because you got 3 goes into 6 twice, and you just have 1 times 1, 2 times 7. So I'm left with s to the 1/14 power there. And this is how they want us to enter it, right? In exponent form. So this would be called exponent form, right? Where I leave everything with exponents, bases and exponents. Now if they wanted it in radical form, I would say this is 2 times and then the 14th root of s. All right, and this would be the exact same thing. They're the exact same expression. Just one's with, exponent everywhere, and this would be called radical form. But they are the same. They want exponent form. All right, so back here, and again, using properties of exponents, product rule, power to a power rule. Right, I'm assuming you know some properties of exponents. All right, so back here, we're just going to say this is equal to 2 times s to the 1/14 power, right? And make sure that 1/14 is in the exponent. I'm sorry, that's tiny there. Again, please read through your answer explanations. All right. Next question. So now the numerator of the fraction is just 1. But the rule stays the same, right? Remember, you can write radicals as fraction powers, write fraction powers as radicals. Alright, so once again, they're asking you to rewrite this expression with a fraction exponent, with a rational exponent. That's all. There's really no simplifying to be done here, I don't think. Let's write it out. Alright, so again, this is in radical form, right, with the radical symbol. They're asking us to write it with an exponent. So the 6 isn't in the radical, so that factor of 6 is going to stay there. So 6 times. And then remember how to write, I showed you earlier the rule, writing radicals as exponents. The 8q, right, the radicand is the base. So in parentheses, I put the radicand, 8q. And then the exponent, the 25th root, that index will be the denominator of the fraction. It's the 1/25th power. And this is all they want us to do. They just told us to take this expression in radical form and write the same thing, an equivalent expression with a rational exponent, a fractional exponent. So very simple. 25th root is the 1/25th power, 1/25 power. And that's it. And the radicand, right, the expression under the radical symbol, is the base on that power. And then you had this factor of 6 that was outside the whole time, right? So that's not going anywhere. Yeah, so that's all they want. 6 times, and then in parentheses, we have 8q raised to the 1/25 power. Again, make sure that's all. It's really tiny, I know, but make sure that 1/25 is all in the exponent. And that's it. That is all they wanted. Just to know that you can go back and forth between radical and exponential form. All right, next question. All right, so we're back to this objective. All right, using the properties of exponents to simplify expressions with rational exponents. Now again, we're going to have to use properties of exponents. Now I've written up the product property, I've written up that power to a power property. This one's going to be an addition property. Right? Remember, you might, again, I'm sure you've seen these before, but when you multiply two expressions with the same base, you keep that base, so y, and then you add the exponents. Right. And I'll write the property up as well. All right, it's the same page here, but again, here's the property of exponents that's being used here. If I take, a to the mth power and multiply it by a again, but raised to the, say, the nth power, right, you're multiplying two expressions with the same base. That'll be equivalent to an expression with that same base, but the exponent will be the sum of the exponents, right? So again, another property of exponents that's being used here. So I'm doing that here, but instead of a, I have y, and m and n are 1/2 and 3/4. So this ends up being y to the 1/2 plus 3/4 power, right? All of this is the exponent on y. And we need to simplify this, right? 1/2 plus 3/4. Right, I'll do this off to the side. Remember, when you're adding, when you add numbers, they need the same denominator. So I would just multiply the first fraction by 2/2, right? This is 2/4 plus 3/4, giving me 5/4. So I've ended up here with y to the 1/2 plus 3/4, so y to the 5/4 power, right? And this is what they want. Right? Y to the 5/4 power. And again, make sure all the 5/4 is in the exponent there. There, please read the answer explanations. Alright. So back to this objective with simplify an expression with rational exponents and a numerator greater than 1. Alright, so this one has a negative exponent. I'll write up another property of exponents that I'm sure you've seen at some point in the past, but still I'll write it up again. A property involving negative powers. Alright, so another property that's useful here, another property of exponents. If I have some number a and I'm raising it to a negative power, say negative m, this is just the reciprocal of the positive power. This is 1 over a to the positive m. Right. So again, another property of exponents that I'm sure you've seen at some point in the past. That's going to be useful here. So what we have here, we have 32 to the negative 2/5 power. So this would be equal to 1 over 32 to the positive 2/5 power. Right. Now if you break up 32 completely, if you factor 32 completely, 32 is 2 to the 5th. So this is 1 over, and then 32 is 2 to the 5th power, right, and that's being again raised to the positive 2/5 power. And now I'm going to use that power to a power rule. We have 1 over 2 to the 5th to the 2/5 would be 2 to the 2nd. Right? Because the 5 times 2/5, the 5's would cancel, you're left with 2. And then 2 to the 2nd is 4. So this ends up being 1/4. And that's as simple as that fraction gets. Now, you could also have done this. Right? You could have also written this as a radical. Remember these rules for radicals here. 32 to the 2/5 power. You could write that as, the 5th root. Remember, I like taking the root first. The 5th root of 32, and then raised to the numerator power, raised to the 2nd. Well, the 5th root of 32 is 2, and then we got, so it's 2 to the 2nd, and that's 4, and again that 4 went to the denominator there, and that was all in the denominator, and I'd end up with 1/4 either way. And that's as simple as that gets. So 32 to the negative 2/5 power is just 1/4. Wonderful. All right, and again, please read through the answer explanations. Next question. All right, now we're back to the expression. The objective, simplify an expression with rational exponents with a numerator of 1. Alright, this is just like an earlier question where I'm given a radical form, right? I'm given it in radical form, and I'm simply asked to write it in exponent form. Right, so this should be pretty simple. Right? Alright, so once again, this is in radical form. There's a radical symbol. I want to rewrite that with exponents. This factor of 5 out here is going to stay there. So 5 times, and then this radical. Right, this will be rewritten. Now remember the radicand, right, the expression underneath the symbol is the base. So in parentheses I'm putting 2w. And then the exponent is going to be a fraction. Right? And this, remember the 7th root would be to the 1/7 power. Right? The denominator is the index. Right. There you go. That's all they want. Just rewrite that expression in exponent form. 5 times 2w to the 1/7 power. Same thing as 5 times the 7th root of 2w. Okay, so 5, and then in parentheses times 2w raised to the 1/7 power. Right, and make sure that tiny 1/7 is in the exponent. Okay, wonderful. And again, please read through the answer explanations. next question. All right, same objective as the last question, but this time it's a little different. We're actually asked to simplify something now instead of just writing it in, something in radical form or something in exponent form. All right, and notice it says enter an integer or a fraction at the end. All right, so we have a 100 to the negative 1/2, which you've seen negative powers earlier, right? I wrote up that exponent property of exponents with negative powers earlier. Negative powers are just the reciprocals of the positive powers. And so here's what we're given, right? 100 to the negative 1/2. And I'll write it again here in words. Negative powers, negative exponents are the reciprocals of the positive power. So here's the positive power, 100 to the positive 1/2. Now you could write 100 as 10 squared, and this is 10, right? But remember, if you want to write this in radical form too, you can. This would be the square root, right? The half power is the square root. This would be the square root of 100. Remember, this is the non-negative principal square root of 100. This is 10. So the answer is 10. Well, no, the answer is not 10, sorry. The positive power is 10. So this, right, is the reciprocal of that. The reciprocal of 10 is 1/10, and that's the final result. That's the answer, 1/10. So 100 to the negative half is 1/10. The reciprocal of 100 to the positive 1/2. Right? So that's one way you could do all these. Or you could have written this out as 1 over 100 to the positive 1/2, right, using that property of negative exponents earlier. But either way ends up being 1/10. Okay. Great. Next. So here we go again. Another one with a numerator of 1. This one I'm going to just say, so this negative 1 out here, this negative sign, like having a factor of negative 1, that's not going anywhere. So this will be a negative number at the end. And then in here you have 25 to the half power. Remember, to the half power means square root. 25 to the half is the square root of 25, which is 5. So this ends up being negative 5 because of the minus sign up front. Very, very simple stuff, I feel. All right. And again, please read through the answer explanations. All right, so one of the objectives is done. Just got to finish up the other two. Okay, once again, I'll just say this one out loud. Now I'll write this one. But still, minus sign out front, that's not going anywhere. That's not part of the base. And then you're doing 81 to the 3/4. 81 to the 3/4. So remember how I like to do it is the denominator is 4. So that means take the 4th root of 81, which would be 3, right? Because 3 to the 4th is 81. The 4th root of 81 is 3, and then raise to the numerator power. 3 to the 3rd is 27. This is going to be negative 27. All right, you know what? I don't need to write it. I just said it. It's negative 27. Again, look at the answer explanations where they're using the they're writing things as radicals, right? You see, they did exactly what I said, right? Take the 4th root of 81, which is 3, and then raise that to the 3rd. Great. All right. This one's just simply write the cube root of w to the 5th as a, well, they say a rational expression. I think they mean, with a rational exponent, right? So here's a radical form expression. They want it to be written in exponential form again. All right, let's write that out. So all you need to do, remember, is that, the radicand, this w to the fifth, is the base. So I'm going to write w to the fifth in parentheses. And then we're taking the cube root of this, and cube root as an exponent is the 1/3 power. And then that power to a power rule, 5 times a third is just 5/3. So this is w to the 5/3 power, and this is what they want. Right? They want you to take it from radical form to exponent form. Right? That's it. So here it is, w raised to the 5/3 power. Okay, great. That objective's done. Read the answer explanations. And it looks like I probably got 2 more questions left with this last one. Again, we're using properties of exponents, and this is another one where I have a product to a power, so I'm going to put that power on each factor. And then we'll have powers to powers, and when you have a power to a power, you multiply them. So I'm going to write all this out. Alright. So as I said, product to a power, I'm going to put that power on each factor, so we have 9 to the 5/2 times, x to the 2/5 to the 5/2 times, and then y to the 3/5 to the 5/2. Now 9 to the 5/2. Remember, I take the square root first, denominator is 2. Square root of 9 is 3. Then 3 to the 5th would be 243. Alright, because 3 to the 4th is 81. Right, times 3 again would be 243. So 9 to the 5/2 is 243. Now here's where it can be a bit tricky. Remember, what we're doing here is, I'm taking an even root outside all this, right? The denominator of this power is 2. This is an even root. So the result should be non-negative. Remember that even root, principal even root? Now if you do this normally, x to the 2/5 to the 5/2, you multiply 2/5 and 5/2, that's 1. You have times x. And then same thing here, y to the 3/5 times 5/2 would be y to the 3/2. Right? You multiply, the 5's would cancel, you'd be left with y to the 3/2. Alright. Now technically, I should have an absolute value around the x here. Right? Because again, I'm taking an even root. So I'm going to enter this way though. Alright, because again, that's tricky to see when you're in powers. It's easier to see when you write in radical form. But I'm going to see that that's what we get. So 243 x. Oh, sorry. So I already typed it in. Let's go back here. Sorry. Yeah, so 243x y to the 3/2, and then let's submit. And yeah, so it looks like you don't have to worry about absolute values when they have the fraction powers, and I'll just leave it alone. All right, just use the properties of exponents. All the properties of exponents that I showed you, a power to a power and product to a power and all that. And don't worry about absolute values here for a moment. Okay. All right, great. So next question. Same objective, right? Use properties of exponents. So we got a lot to use here. I'm seeing some negative powers. Seeing numerator, denominator factors of x. All right, so lots of stuff to write out here. Let's do it. All right. So the one thing that's annoying me a little is that none of these powers are fractions. So I don't know why this particular question is in this assignment. Please know that you might see a question like this where some of the powers are fractions, but you're still using the same rules. So I've put product to a power, I've put power to a power, negative powers, I've put those properties up. The only one I haven't put up is the quotient power, the quotient property. If I take an expression a to the nth power and divide it by that same expression, that same base, a to the nth power, the resulting quotient will have the same base, and the exponent will be the numerator power minus the denominator power. Alright, so that's really the only other property of exponents that we'll need for this particular problem. Alright, so I'll worry about the negatives in a little bit. So we have 2 to the negative third times x to the negative first times, and then here we got a product to a power. So times 3 squared times y squared squared. Right. And then same thing in the denominator. I have a product to a power. So we have x to the negative third to the negative third power again, times, and then y squared to the negative third. Right. And again, I'll worry about all the negative powers at the end. Well, you know what? I'll just do this right. Alright, tell you what. Yeah, I'll worry about the negative powers at the end. So we have 2 to the negative third times x to the negative first times, 3 squared is 9, and then y squared squared, power to a power, that's y to the fourth. Alright, then we have x to the negative third to the negative third, power to a power, you multiply those, that's x to the positive 9. Then y to the negative sixth. Alright. So now I have the following. Now, 2 to the negative third is 1/8 times 9 would be 9/8, right? So I've got 9/8. Right, 9/8 is a factor in the numerator. And then now you have a bunch of division with the same kind of base, right? The same base. You have x to the negative first over x to the ninth. So according to this, that would be x to the negative 1 minus 9 power. And then I also have, y to the fourth as a factor in the numerator, y to the negative sixth in the denominator, y to the fourth divided by y to the negative sixth, that'd be times y to the 4 minus negative 6. Numerator power minus denominator power. So this is 9/8 times x to the negative 10th times y to the positive 10th, right? 4 minus negative 6 would be 4 plus 6. All right, and then we're asked to simplify, right? So no negative powers, right? Usually when they ask you to simplify, they don't want negative powers. So remember, x to the negative 10th there would be 1 over x to the 10th. And then I have, y to the positive 10th. And then multiplying the numerators, I get 9 y to the 10th. Multiplying the denominators, I get 8 x to the 10th. And this would be considered simplified. No more negative powers. The numerator and denominator don't have any common factors. Right, so that was a lot. All right, but you're using lots of properties of exponents. Products to powers, powers to powers, negative powers, right? And eventually getting it down to the point where there's no negative powers, and the numerator and denominator have no common factor. So this is what I'm entering: 9y to the 10th divided by 8x to the 10th. 9y to the 10th power, then divided by 8x to the 10th power. And that should be good if I did everything correctly. Wonderful. All right, and again, please read through the answer explanations. Great, and then again, they're doing it similar way to what I did, using properties of exponents. And that should be it, all right, for this version of this assignment. Please remember that, I said this at the top of the video too, right? The version you saw me do just now may or may not have the same questions that you're going to see, right? So don't just copy what I'm writing, right? Work on it yourself. But the objectives are the same. The types of questions will be similar. The way I would go about doing them would be similar. So I'm hoping watching me go through these 12 questions here, helps you out when you're working on this assignment on your own. And thank you very much for watching.